Well, the line junction denotes carbon atom, while the line junction carbon atom with H must be according to valency. Okay, carbon atom bonded to appropriate number of hydrogen required to satisfy the valency of carbon. Okay, atom. Some of the examples are represented as follow: 3-methyl octane. 3-methyl octane can be represented as 3-methyl octane. 3 किस ग्रुप में है मिथाइल? 3-methyl octane. 3 नंबर पे मिथाइल है, ट्राई नहीं बोला है ना. 2 3 3-methyl octane. Various way of representing 2-bromobutane are 2-bromobutane. 2-bromo, B-R-O-M-O, bromobutane. B-U-T-A, butane, T-A-N-E, tane, yes, 2-bromobutane. Meth, eth, prop, bu. 1 2 3 4 2 नंबरमा ब्रोमो छ. ब्रोमोब्युटेन, BR. Butane. Okay. In cyclic compounds, the bond line formulas may be given as in cyclic compound chain. Chain, bond line formula. In cyclic compound, bond line formula. Bond line formula in cyclic compound. Cyclopropane, propane, cyclopentane, cyclochlorohexane. Pentane, cyclohexane, chloro. Cyclohexane, HEX, hexane. Chloro. Cyclochlorohexane. Expand each of the following condensed formula into their complete structural formula. Complete structural formula. CH3, CH2, COCH2, CH3. Complete structural formulas. 1 2 3 4 5. COCH2, CH3, COCH2, CH3. 1 2 3 4 5. 1 2 3 4 5. C double bond O. Hydrogen. Hydrogen. CH2, C double bond, CH2, CH2, CH3, C double bond O, CH2, CH3, CH3, CH double bond CH, CH2, CH3, C double bond C, CH3, 1 2 3 4 5 6 7, CH3, 1 2 3 4 1 2, CH3, CH double bond CH, CH2, 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 CH3, CH. The last one is CH3, 3 CH2 and CH3. For each of the following compounds, write a condensed formula and also their bond line formula. For each of the following compounds, write a condensed formula and also their condensed formula. It is already condensed. Okay. For each of the following, condensed formula. Condensed formula. The following compounds, write a condensed formula and a bond line formula. Condensed formula and bond line formula. CH2, 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 CH, CH3, CH, O, CH2, CH2, 1 2, 1 2 3, and then CH2, 1 2 3, CH2 whole twice, CH2 whole twice, OH, CH2, CH2 whole twice, CH, CH3, CH, CH3 and CH3, OH, CH2 whole thrice, CH2 whole thrice, CH, CH3, CH, CH3 whole twice, CH3 whole twice. So this is OH, CH2, OH, CH2, OH, CH2 whole thrice, CH, CH3, CH, CH3 whole twice, OH, CH2, OH, CH2 whole thrice, CH, CH3, CH, CH3 whole twice. Correct. The other one is CN, CN whole twice, CH, OH, OH, CH, CN whole twice. Correct. It's okay. 1 2 3, CH3 CH3 whole twice. Okay, OHCH2 whole thrice, CH3 whole twice, CH3 whole twice. B. NC N triple bond C ನಮ್ದಲ್ಲೆಲ್ಲ CH OH C triple bond N. Okay, OH CH CN whole twice, OHCH CN whole twice. Okay, it's okay ma, astaghfirullah. Bond line structure. Which okay, 1 2 3 4 4 1 2 3 1 2 3 4 1 2 3 1 2 3 4 1 2 3 4 CH3 1 2 3 it's okay. OH no 1 2 3 don't tell me this. 1 2 3 4 5 6 1 2 3 4 5 6 1 2 3 4 6 7. So ये वाला 1 1 2 3 4 5 6. Okay, so 1 2 3 4 5 6 2 3 4 5 6. Okay, 1 2 CH3 बोला है यहाँ पर CH3 OH ना 1 2 3 4 and then 5 पे भी एक CH3 okay, फिर CH3 ये वाला होगा ना 3 4 5 6. I don't know. Which group होगा? CN Expand each of the following bond line formula to show all the atoms including carbon and hydrogen. All the atoms including carbon and hydrogen. Including carbon and hydrogen. Expand each of the following bond line formula to show all the atoms including carbon and hydrogen. Okay. Expand each of the following bond line. Expand each of the following bond line formulas to show all the atoms including carbon and hydrogen. Okay. Bond line formulas to show all the atoms. Okay. Expand each of the following bond line. Expand bond line formula to show all the atoms including carbon and hydrogen. Expand bond line structure formula to show all the atoms including carbon and hydrogen. Three hydrogen. With what? CH3. This is CH3. Yes, she got one more hydrogen. H2, CH2. 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there are 8 carbons. Okay, so here CH3, CH3, CH2, CH2, CH2 again, CH3, CH2, CH2, CH3, CH2, 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 One, two, three, four, five, six, seven, 8. There are 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8 here. One, two, three, triple bond, carbon, OH, CH, 1, 2, 3, C, CH2, CH, OH, CH3. CH, CH. CH2, CH2 लिखना होगा तो नहीं बना के दिखाना है. ओके, CH, CH. here CH3, 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 CH3. I don't like it. The three-dimensional representation of organic molecule. At least the half portion of 35 is 34 divided by 2. 2 ones are 2, 1, 2 sevens are 14, 17, 7.5. Okay. 1, 2, 3, 4, 5, 6. Resonance आएगा, hyperconjugation आएगा, हाई सब हाई. 3-dimensional representation of organic molecule. Three-dimensional representation of organic chemistry, organic molecules. Three-dimensional representation of organic molecules. The three-dimensional 3D structure. Three-dimensional 3D structure of organic molecules can be represented on paper by using certain conventions on paper. The three-dimensional 3D structure of organic molecule can be represented on paper by using certain conventions. For example, by using solid and dash wedge formula. Okay, using solid and dash wedge formula. Okay, wedge formula. The 3D image of a molecule from a two-dimensional picture can be perceived. 3D image of molecule from two-dimensional picture can be perceived by solid and dash wedge formula. Okay, in this formulas, the solid wedge is used to indicate a bond. Solid and dash wedge formula. In this formula, the solid wedge is used to indicate the bond projecting out of the plane of paper. In this formula, the solid wedge is used to indicate a bond projecting out of the plane of the paper towards the observer. towards the observer. The dash which is used to depict is used to depict the bond projecting out of the plane of the paper. 3D maze of molecule from two-dimensional picture can be represented. In this formula, the solid which is used to indicate a bond projecting out of the plane. Plane देखिए बाहर निकल देसा plane out of the plane of paper towards the observer. The dash which is used to depict the bond projecting out of the plane paper and away from the observer. It is away from the observer. Okay, projecting outwards but away from the observer. Okay, which are shown in such a way that the broader end of which is towards the observer. Okay, towards the observer. The bond lying in the plane of the paper are depicted by using a normal line. 3D representation of methane molecule on paper has been shown. Okay, those two hydrogen bonds of methane are on the plane of the paper, bonds in the plane of the paper. Dash which bond away from observer. Okay, solid which bonds towards observer. The dash which is used to depict the bond projecting out of the plane of the paper away from the observer, which are shown in such a way that the broad end of the wedge is towards the observer. Broad end is toward the observer. Bond away from observer. Solid wedge bond towards observer. Wedge and dash representation of methane. Okay, got it. Just one. I see. Three-dimensional structure of organic 3D structure. Three-dimensional structure of organic molecule. 3D structure of organic molecule on paper. Using solid and dash wedge and dash formula. WEDG wedge and dash 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 formula wedge and dash formula. Solid and dash wedge formula. The 3D image of molecule from two-dimensional picture can be preserved. Okay. Solid dash 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 solid wedge dash wedge. Study of molecule of two. Okay, wedge formula. The 3D image of molecule from a two-dimensional picture can be perceived. In this formula, the solid wedge is used to indicate a bond projecting out of the plane of the paper towards the observer. In this formula, the solid wedge is used to indicate a bond projecting out of the plane towards the observer. The dash wedge is used to depict the bond projecting out of the plane of the paper and away from the observer. Depicted by using normal line. Bonds lying in plane. Bonds lying in plane. Astaghfirullah. In these formulas, which are shown in such a way that the broad end of the wedge, okay, you did this one, right? Solid wedge. This is a solid wedge. Astaghfirullah. Solid wedge. 3D maze of molecule from a two-dimensional picture can be perceived. In this formula, the solid wedge is used to indicate a bond. Solid wedge is used to indicate solid wedge. It indicates a bond projecting out of the plane of the paper. It indicates a bond projecting out of the paper towards the viewer. Out of the plane of paper. Out of the plane of paper, right? Yeah. In these formulas, the solid wedge is used to indicate a bond projecting out of the plane of the paper towards the observer. Towards solid wedge, towards the observer. Towards the observer. Broad edge of the wedge. Broad end of the wedge is BROAD. Broad end of wedge must be towards the viewer. Edge is towards the viewer. 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 The dash wedge is used to depict the bond projecting out of the plane. Okay. In this formula, the solid wedge is used to indicate the bond projecting out of the plane of the paper towards the observer. The dash wedge is used to depict the bond projecting out of the plane of the paper away from the observer. Okay. This dash wedge. DASHED. Dashed wedge. Dash wedge. Paper towards the observer. The dash wedge is used to depict the bond projecting out of the paper. No. Dash wedge. Depicts PI. DEPI. The bond projecting out of the plane of the paper. Projecting out of the plane of paper. Projecting out of the plane paper. Depicts the bond projecting out of the plane of the paper away from observer. Away from observer. Away from observer. Away from observer. Methane. Wedge and dash representation. Wedge and dash representation of methane CH4. Molecular model. Molecular models. Molecular models are physical devices. Molecular models are physical devices. What are they? Physical devices. They are just physical devices. Molecular models are physical devices that are used for a better visualization. Molecular models are physical devices. Molecular models, physical devices that are used for better visualization and perception of three-dimensional shapes of organic molecules. 3D shapes of organic molecules. Better visualization and perception. These are made up of woods. These are made up of wood plus इसको बोलते हैं molecular model. अच्छी बात है. Molecular model. These are made up of wood, plastic, metals and are commercially available. Commonly, 3 types of molecular models are used. Framework model, ball and stick model, molecular model, framework model, space filling model, and then commonly 3 types of molecular models. Three types of molecular models. Physical devices, molecular models. Okay, इसको भी बना ही देते हैं, दो important नहीं है. Molecular models. Physical device. Better visualization. Used for better visualization and perception. Three-dimensional shape. Perception of 3D shapes. SHAPES. Of organic molecules. 3D shapes of organic molecules. They are made up of wood, plastic, metal, or are commercially available. 3 types. Molecular model types. Framework model, ball and stick model, space filling model. Framework. Space filling. Ball and stick model. Stick. framework model, space filling model, balls and stick model. Okay. In the only the bonds connecting the atoms of a molecule and not the atoms themselves are shown. This model emphasizes the pattern of bonds of molecules while ignoring the size of atom. Okay. Framework model. Framework model. Framework model. Only bonds are shown. Bonds are shown. SHO and shown. Only bonds are shown. Okay. Framework model. Only bonds are shown. Bonds connecting the atoms of molecule. Only the bonds connecting the atoms of a molecule and not the atom themselves are shown. Atoms are not shown. SHO shown. Okay. Only the bond connecting the atom of a molecule and not the atom themselves are shown. This model emphasizes the pattern of bond of molecule while ignoring the size of atom. This model emphasizes the pattern of the molecule. Ignores the size of atom. Ignores the size of atom. Emphasize the pattern of bond. Focus on pattern of bonds of a molecule. Pattern of the focus on the pattern of the bond of a molecule. Focus on the pattern of the bond of the molecules. While ignoring the size of atom. Ball and stick framework. In ball and stick model, both the atoms and the bonds are shown. In ball and stick model, both the atoms and the bonds are shown. In the ball and stick model, both the atoms and the bonds are shown. Ball and stick model. Both the atoms and the bonds are shown. In the ball and stick model. Both atoms and bonds are shown. Atoms and bonds are. Balls represent atoms and the stick denotes the bond. Ball represents atoms and the stick denotes the bond. Compound containing C double bond, example ethene, can be best compound containing C double bond C, example ethene, can best be represented by using spring in place of stick. place of a stick. These models are referred to as ball and spring models. Spring. Astaghfirullah. Springs are used in place of bond. This model is called ball and spring model. The space filling model. Space filling model emphasizes the relative size of each atom based on the van der Waals radius. Bones are not shown in this model. It conveys the volume occupied by each atom in the molecule. In addition to this model, computer graphics can also be used for molecular modeling. Computer graphics भी use कर सकते हैं molecular modeling के लिए. Molecular modeling के लिए. Space filling model. The relative size of each atom. Okay, these models are referred as ball and spring model. The space filling model emphasizes that give importance to relative size of emphasize size of the atom. Relative size of each atom. Emphasize relative size of each atom. Emphasize relative size of each atom based on its van der Waals radius. Based on its van der Waals radius. Based on its van der Waals radius. Emphasize size of the atom. Relative size of each atom. Emphasize the relative size of हर एक atom. Emphasize the relative size of each atom based on van der Waals radius. It's okay, ma. Van der Waals radius. Based on its van der Waals radius. Bones are not shown in the model. Bones like you said, they have a model now. This is the relative size of each atom based on van der Waals radius. Bones are not shown as shown. Bones are not shown. The space filling model emphasizes the relative size of each atom based on the van der Waals radius. Bones are not shown in this model. It conveys the volume occupied by each atom in the molecule. It conveys the volume occupied by each atom in the molecule. Conveys the volume occupied by each. Bones are not shown in this model based on its van der Waals radius. Based on its van der Waals radius. Relative size. Bones are not shown in this model. It conveys the volume occupied by each atom. It conveys the volume occupied by each atom in the molecule. Bones are not shown in this model. If they convey the volume occupied by each atom in the molecule, it conveys the volume occupied by each atom in the molecule. Computer graphics. Molecular model. Graphics. Computer graphics. Space filling model. This is space filling model. Ball and stick model. Framework model. This molecular computer graphics. Computer graphics can also be used for molecular modeling. Space filling model emphasize the size of the molecule, emphasize the size of each atom based on van der Waals radius. Based on its van der Waals radius. Bones are not shown in this model. Bones are not shown in this. इसमें बॉन्ड नहीं दिखाया जाता, बस वॉल्यूम कितना ऑक्यूपाई हुआ है वही दिखाएगा. Convey the volume occupied by each atom in the molecule. Convey the volume occupied by each atom in the molecule. Convey the volume occupied by each atom in the molecule. Convey the volume occupied by each atom in the molecule. Okay. Classification of organic compounds. Computer graphics. Classification of organic compounds. The existing large number of organic compounds and their ever increasing number has made it necessary to classify them on the basis of their structure. Organic compounds are basically classified as follows. Classification of organic compounds. The existing large number of organic compounds and their ever increasing number. The existing large number of organic compounds and their ever increasing number has made it necessary to classify them on the basis of their structure. On the basis of their structure, organic compounds are broadly classified as follow. Compounds increasing need of classification. Classification of organic compounds. Okay. Basis of their structure. On the basis of their structure, organic compounds are broadly classified as follow. Moreover has made it necessary to classify them on the basis of their structure. On the basis of classification of organic. Structure. On the basis of their structure, acyclic or chain compound, cyclic or closed chain or ring compound. Acyclic / open chain. Acyclic / open chain compound. Cyclic. Ring or closed. Homocyclic of carboxylic compounds, heterocyclic compounds. Homocyclic or carboxylic compound. Homocyclic or carboxylic compounds. Okay, or heterocyclic compounds, homocyclic. Cyclic compounds. Homocyclic, cyclic or carboxylic compound or carbocyclic, homocyclic or carbocyclic. यो कार्बोक्सिलिक होइन, कार्बोसाइक्लिक हो, CYCLIC, कार्बोसाइक्लिक. होमोसाइक्लिक एउटै टाइप हुन्छ, कार्बन हुन्छ. होमोसाइक्लिक और कार्बोसाइक्लिक कम्पाउन्ड्स. होमोसाइक्लिक और कार्बोसाइक्लिक कम्पाउन्ड्स. कार्बोसाइक्लिक र होमोसाइक्लिक. हेट्रोसाइक्लिक कम्पाउन्ड. कम्पाउन्ड्स के हुँदैन? कम्पाउन्ड्स. Homocyclic, acyclic, alicyclic compound, aromatic compound. Alicyclic compound, aromatic compound. Benzenoid compound, non-benzenoid compound. Homocyclic or carbocyclic compounds. Aromatic compounds are alicyclic, 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 CYLIC, alicyclic, CYCLIC, alicyclic compounds. Alicyclic compounds, alicyclic compounds. Alicyclic compounds. Alicyclic, CYCLIC, cyclic compounds, aromatic compounds. Aromatic compounds. Alicyclic compounds or aromatic compounds. Okay, alicyclic, 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 alicyclic compounds, aromatic compounds, alicyclic compounds, aromatic compounds, aromatic compounds मा पनि दुईटा हुँदो रहेछ, एउटा बेन्जिन भएको एउटा नन बेन्जिन भएको. Okay, so organic compound लाई classify गर्नु necessary छ because there is a huge number of existing organic compounds. On the basis of this structure, we can classify it. First, there is chain, acyclic or chain compounds, acyclic or open chain compounds, correct? And the other one is ring, closed chain or cyclic compounds. Cyclic compounds are of two types, heterocyclic and homocyclic. Homocyclic is also known as carbocyclic because only carbons are present there. Then we have again homocyclic is divided into two types, alicyclic and aromatic. Aromatic is further divided into two types, benzenoid and non-benzenoid compounds. Benzenoid compounds and non-benzenoid compounds. Benzenoid and non-benzenoid compounds. Alicyclic, aromatic, acyclic, open chain compounds, alicyclic, closed chain or ring compounds, aromatic. Guys, I'll go and bring tea for myself. Okay, I'm kind of sleepy, though I don't want to sleep. I have to cover a lot of syllabus, so I'll go and make tea for myself and then I'll come back. Compound. These compounds are also called aliphatic compounds. Acyclic or open chain compounds. These compounds are also called aliphatic compounds and consist of straight or branch chain. Okay, acyclic or open chain compounds. These compounds are also called as aliphatic. Acyclic, aliphatic, and open chain are same. Aliphatic compounds and consist of a straight or branch chain compound. Straight भी हो सकता है, branch भी हो सकता है compounds. For example, CH3, ethane, isobutane, Mr. Probio, isobutane, acetaldehyde, acid, it, 2 carbons, acetic acid. 2 carbons. It's okay, man. It's okay. Acyclic or open chain. Aliphatic compounds and consist of NB, straight, can be straight or branch chain. Example, hey, it's okay. Ethane, isobutane. Acetaldehyde, acetaldehyde, 2 carbon. Ethane or ethane, CH3 CHO. Is it CH3 CHO? acetic acid. Acetic acid, CH3 C double bond O OH. This is aliphatic, acyclic or chain compounds. Open chain compounds are also known as aliphatic compounds. Excuse me. Is alicyclic or alicyclic or cyclic loose chain or ring. Loose chain ring. Alicyclic. Aromatic compounds. Benzenoid aromatic compounds, non-benzenoid compound, okay? Heterocyclic aromatic compounds, functional group IO. From there the real chapter starts. Alicyclic closed chain or ring compound, alicyclic or aliphatic. That is also aliphatic. Alicyclic or closed chain or aliphatic compound. Aliphatic cyclic, okay? Aliphatic cyclic compounds contain carbon atoms joined in a form of a ring. Homocyclic. Sometimes atoms other than carbon are also present in the ring. Heterocyclic. Astaghfirullah. Okay.